Welcome to this lesson on the basics of differentiation. By the end of this video, you will be able to derive functions in the form of x to the power of n, where a is a rational number and n is a positive integer. We will also look at how to handle expressions with multiple terms, and we will ensure you are comfortable using the dy by dx notation. Differentiation is a fundamental part of calculus that allows us to find the gradient, or the rate of change, of a curve at any specific point. To begin, let's look at the general rule for differentiating a single power of x. This is known as the power rule. If y equals a times x to the n, then dy by dx equals n times a times x to the power of n minus 1. To find the derivative, denoted as dy by dx, we follow two simple steps. First, we take the original exponent n and multiply it by the coefficient a at the front. Second, we reduce the power of x by exactly 1. Let's try a basic one. If y equals x cubed, our n value is technically 1, and our n value is 3. Following the rule, we bring the 3 down to the front. Then, we subtract 1 from the power, leaving us with 3x squared. We have successfully applied the power rule to a basic function. Now let's see how this works when the coefficient is a fraction, or a larger integer. Let's apply this to a case where the coefficient is a rational number, which is a common feature in IGCSE exams. Consider the function y equals 1/2 x to the power of 4. Here, our coefficient a is 1/2 and our power n is 4. To find dy by dx, we multiply the front by the power of 4. 4 times 1/2 gives us 2. Then, we reduce the power from 4 down to 3. So, the derivative is 2x cubed. What about a linear term like y equals 5x? Remember that x is the same as x to the power of 1. If we multiply by the power, we get 5. Subtracting 1 from the power gives us x to the power of 0. Since anything to the power of 0 is 1, the derivative is simply 5. This makes sense because the gradient of a straight line is constant. We've now mastered single terms with various coefficients. Take a moment to think. What would happen if we had a constant, like y equals 7, with no x at all? Since the gradient of a horizontal line is 0, the derivative of any constant is always 0. In your exams, you will often be asked to differentiate expressions with multiple terms. The good news is that you can differentiate each term one by one. This is known as the sum rule. If y equals f of x plus g of x, then dy dx equals f prime of x plus g prime of x. This is called the sum rule. Essentially, the plus and minus signs act as separators. You apply the power rule to the first part, then the second, and so on. Let's look at a worked example. Find dy dx for y equals 2x cubed minus 5x squared plus 4. We will process this three-term expression term by term from left to right. For the first term, 2x cubed, we multiply 2 by 3 and decrease the power by 1, giving us 6x squared. For the second term, minus 5x squared, keep the minus sign. 2 times 5 is 10, and the power drops to 1. We just write this as minus 10x. Finally, the constant 4. As we discussed, the derivative of a constant is 0, so it effectively disappears. Putting it all together, our gradient function dy dx is 6x squared minus 10x. You can now handle complex polynomial expressions by breaking them down into simpler pieces. To finish, let's work through a problem exactly as you might see it on an IGCSE paper. These questions often combine fractions and multiple terms to test your precision. A curve has the equation y equals 1/3 x cubed plus 3/2 x squared minus 5x. Find the expression for dy by dx? Notice we have three terms, and the coefficients are rational numbers. Don't let the fractions intimidate you. The steps remain the same. For the first term, we bring down the 3. 3 times 1/3 is simply 1. Subtracting 1 from the power gives us x squared. For the second term, we bring down the 2. 2 times 3/2 is 3. Reducing the power from 2 to 1 gives us 3x. Finally, for minus 5x, the derivative is just the coefficient, which is minus 5. So, the gradient function for this curve is x squared plus 3x minus 5. We have now covered all our objectives. You can derive power functions, handle sums of up to 3 terms, and use the dy by dx notation confidently. Practice these steps, and you'll find differentiation to be one of the most consistent marks you can earn in your exam.